Hi, welcome to this video where we will learn alkanes as tested in the A-level chemistry in 10 minutes. So now let's talk about alkanes. So what are alkanes? So alkanes are basically organic compounds with just C and H. And all the bonds in an alkanes are single bonds. So if you have a hydrocarbon, meaning a molecule with just carbon and hydrogen, and you only see single bonds, then it is an alkane. Alright? And we know that alkanes are nonpolar because they only have C and H, and CH bonds are considered nonpolar. And also because they only have single bonds, they are considered saturated. Generally, we can split alkanes into two groups. One of it is the aliphatic alkane. So aliphatic alkanes, I will see it as an alkane that doesn't have any rings, okay? While a cyclic alkane is one that has a ring structure, okay? So in terms of reaction, there isn't much difference, or there isn't any difference in the reactions of your chain alkanes versus your cyclic alkanes. But there's a difference in the general formula. So if you have an alkane that doesn't have a ring structure like those here, okay, then its formula, its general formula will be CnH2n plus 2, where n is the number of carbons. But if you have an alkane with a ring structure, then for each ring structure that it has, the number of hydrogen will decrease by 2. So if you have to look at alkanes with just one ring, then the general formula will be CnH2n. Okay, in other words, you compare it with this, it's actually 2 hydrogens less. Okay, and if you have an alkane that has two ring structures, then the general formula will be CnH2n minus 2, and so on. Alkanes are not reactive. In fact, in your entire A-level syllabus, they are the ones that have the least number of reactions. Okay, so what are the key reactions? Well, one of it is combustion. So alkanes can undergo combustion, and if it undergoes complete combustion in excess oxygen or excess air, then carbon dioxide and water will be the only product. Okay. Alkanes, this is cracking is another reaction that alkanes undergo. So your large crude oil molecules, they can be made into useful products by cracking. So big alkanes can form smaller molecules. There is many possible equations that you can write for cracking. It really depends on the conditions that you use for cracking. So in general, as long as the reaction is a balance, or the equation is a balanced one, it is a possible cracking reaction. Okay, cracking is not in your A-level syllabus, but it is an important industrial process. Okay, so what you need to know, just remember, cracking involves breaking down of a big alkane molecules into smaller molecules. Next reaction, which is the most important for this chapter, or the most important reaction for alkanes in your A-level syllabus, is the free radical substitution. So free radical substitution involves the reaction of an alkane with a halogen such as chlorine and bromine to form a halogenal alkane. So let's look at free radical substitution in detail. So I'll give an example of a free radical substitution. Let's use an example of methane reacting with chlorine. Okay, the condition that is required for this will be either UV light or heat. Without UV light or heat, the reaction will not take place. Okay. So the free radical substitution, if we were to look at the mechanism, it involves 3 steps. The first step is the initiation step. And this is the step that requires you pumping in the energy in terms of UV light or heat. So in the initiation step, homolytic fission of the Cl-Cl or the halogen bond occurs, and you will form free radicals. Okay, and because bond breaking is endothermic, energy has to be supplied, and that is why we need UV light or heat for the reaction. Okay, it is to break the halogen-halogen bond. Okay, so we supply UV light or heat to break this Cl-Cl bond, and each of the chlorine atom will get the electrons in the bond. and you'll form a chlorine free radical. A free radical is basically an atom with an unpaired electrons. So recall chlorine is in group 7. So in group 7, atoms have 7 valence electrons. Okay, if there are 7 valence electrons, in other words, it means that there's one unpaired electron, and this one unpaired electrons makes chlorine really unstable because it is just short of one electron to achieve stable octet configuration. So therefore, it reacts readily. So once we have formed this chlorine free radical, it will go on to attack other molecules so that it can get its octet configuration. So the chlorine free radicals will attack the methane molecule. So it will form a bond with H, all right? Okay, and because it took away a H with an electron here, you end up having a methyl free radical being produced. Okay, this methyl free radical, because it is a free radical, it is also highly reactive, so it will want to react with other molecules so that it becomes stable. So what it does is it will react with another chlorine molecule, okay, and it forms halogenal-alkane, and at the same time it forms a free radical. Okay, so once you have formed a free radical, so you notice your chlorine free radical is being regenerated, and it can go on to attack other methane molecules and other molecules as well. So this reaction will propagate, okay, because every step produce a free radicals that can keep the reaction running. Okay, so that is why we call this step a propagation step. Okay, the propagation step produces free radicals, so does the initiation step. Okay, so if there are free radicals in the reaction will continue. So in the third step, which is the termination step, we actually the words means terminate. So it tries to terminate the reactions. So to terminate the reactions, you need to get rid of the free radicals, or the free radicals have to be converted to molecules. So one way for converting the free radicals to molecules is through the termination step, where free radicals, they collide with each other, and you see there's one electron here, one lone electron here, and one lone electron here, and they can form a covalent bond with each other. So notice the product of this is a molecule, and there are no other free radicals being generated. So the termination step actually gets rid or convert the free radicals into something else. So as you get more and more molecules undergoing the termination step, you have less and less free radicals available for the reaction to proceed. Okay, and the reaction stops when your reaction runs out of free radicals. All right, so for the termination step, right, any two radicals can collide with each other to form a molecule. So although our main product here should be the halogenal alkanes, or CH3Cl, we do have other radicals like chlorine radicals, methyl radicals, and there's not just one of them, there will be many of them. So two chlorine radicals could collide with each other to form Cl2. Similarly, two methyl free radicals could collide with each other to form ethane. So it tells you that for a free radical substitution reaction, right, there are a lot of side products formed. Okay, this is the main reactions, but we do have many other byproducts being formed. So if you want to have a high yield of chloromethane, free radical substitution will not be a good reaction to choose from, okay, to use to produce chloromethane because of the many byproducts. Okay, so I want you to remember the free radical substitution in detail. In fact, it is the most important reaction, or the most important concept in this chapter on alkanes for A levels. Thank you for watching this video, which is proudly presented by learnalevelchemistry.com. Do check out our website at learnalevelchemistry.com for more A-level chemistry resources. Also, please like and subscribe to our channel. It really motivates us. Meanwhile, do check out our other videos. See you!